All right. Hello, everybody, and welcome to the stream. I hope everybody's doing all right tonight. Tonight we are going to pick up rather where we left off on the last stream. So as folks file into the stream on both sides, I will go ahead and just take a quick minute to thank the supporters of the channel, starting with our partners, who are the highest tier of subscription over on YouTube memberships and Patreon. They are Gabby Bashir and Gerboles Inc. I'd also like to thank all the other supporters listed on the screen here. They are a combination of the other tiers of subscription on YouTube memberships, Patreon, as well as Twitch subscriptions. So thank you all very much for your support. It is greatly appreciated. And, of course, I hope it goes without saying that I appreciate each and every one of you viewers here on Twitch or over on the YouTube side. We are simulcasting, so I do watch both chats. Thank you to you guys as well for being here, following along, and interacting. That being said, this is an interactive stream, so if you have something you want to discuss or whatnot, feel free to jump into the chat. I do keep an eye on them, right? With that being said, let's see. Let's double-check the chat. Painson, hello. How are you doing tonight? Good to see you. And Rohit, good to see you as well over on the YouTube side. Hello. Welcome to the stream. All right. So tonight we're going to talk about a few different things. So we're basically going to finalize our level of detail that we are working out on our terrain chunks, which I've actually already gone ahead and done that off camera. So we're going to take a look at that. And I've also done some performance improvements off camera, so we'll take a look at those as well. And we're going to talk about shader hot reloading as well. So that is something we've been needing to add for quite a bit. And then we're also going to look at getting some adjustable properties in for our PBR shaders, right? So that's kind of what's on the agenda for tonight, anyway. I'm all right, Painson. I have a couple of things I need to go over, but I'm going to wait till a few more folks are on the stream to mention it. So today is a little bit of a bittersweet day, actually. So we'll talk about that in a bit. Cry, hello, over on the YouTube side. Welcome. Good to see you here. All right. So let's go ahead and take a look at the GitHub. So here is that, and we're going to take a look at the terrain chunk branch. So we've had a number of commits that were made. Specifically, let's see. It looks like probably, let's see, when was the last stream would have been the 18th. Yeah, so it's going to be everything from here down, right? So we basically got the terrain skirt geometry working. I did figure that out. Actually, these two commits are kind of doing the same thing. It's just I only committed part of it for some reason, I think because I was in the wrong folder or something. So these two commits are part of the same thing. And then we performed a little bit of performance increase on buffer uploads, and we'll talk about that. And then we did a little bit of cleanup on our terrain chunk logic. So I want to talk about those things, and we can knock those out real quick. And then what we'll do is we'll get this branch merged into main. I'm sorry, 0.6, right? And then we'll go ahead and tackle the shader hot reloading, right? Okay, so with that, I guess let's open up these two. And a lot of this is just basically changing the way that these loops were working, more or less, right? So it was changing offsets and things like that. So most of this isn't like gigantic changes, even though it looks really long. So the biggest sets of changes were having to do with the vertex data length, which we've already talked about this a little bit. So instead of doing image width and height on the pixel count on this, and just using that pixel count as the vertex data length when we're loading in the height map resource, we actually add an additional 1 to that. The reason that we do that is because if we think about the way that we have our terrain geometry, if we have 16 tiles, we have 17 rows of vertices, right? But each one of our tiles essentially is a individual pixel in the array. So we're eventually going to get to a point where we try to loop back on the final row of vertices because we don't actually have any data there, right? And so to get around that problem, what we basically do is we take the last row of image data and we duplicate it, right? And that gives us what we need to sort of round out the terrain at the very end. So there's that. And then let's see. When we're loading up the terrain itself, we change this loop a little bit to take into account the new dimensions, right? So this loop actually is pretty much the same, but this loop down here is new. It contains a little bit of duplicated code. We can clean that up at some point, but I'm not really too worried about it in this instance, right? So basically what we do here is we iterate the last row of the image and sample the height from there, and then just move on, right? So that's what this is doing. And that gives us the that vertex data that we use to sample the height. That gives us the proper size for that. And then I think the rest of this is pretty much just formatting stuff. Let's see. Yeah, more or less. All right, so that's it for the terrain loader. Most of the other changes are actually in the terrain C file. So we've gone ahead and separated out the terrain chunk destroy and the terrain chunk calculate geometry. So this calculate geometry is a function that works on an individual chunk and then takes the offset X and Z. So that is basically fed by a loop that's a little bit further down here that we'll get to in a second. So as you can see, this terrain create is mostly the same. We just had to do some index adjustment on that, right? So I'm not going to go into every single one of these things. I think if you look at the diff, it kind of makes sense. So I just did some cleanup of some of this stuff there. We also did a check in terrain destroy to say, hey, if the generation of the terrain is not invalid ID, meaning it's been loaded, that we should try to unload it before we actually perform the destruction of it, right? And then instead of performing this destruction here in line with this terrain destroy, we simply moved that off to a terrain chunk destroy, which is a private static method, right? And so that's where all that's been moved to. We also invalidate the unique ID. Our terrain initialize calls now into that terrain chunk calculate geometry. So before this was kind of done in line. Now it's done. It's just been separated off to a function to make it a little bit easier to follow. Terrain load has kind of had the same thing happen to it, where we have a terrain chunk load that gets called. So that's here, right? So we've sort of offloaded some of the work there. Most of this is still the exact same logic that we had there. The unload is the same thing. We offloaded some of that logic to an unload, which is here, right? And then the terrain chunk destroy is down here, right? So that's just static. So I just moved it to the bottom. That's all that is. And then the generate geometry is where the biggest changes happened. So most of these changes are, again, just indexing type of stuff, right? The other thing that we did, though, was as we are going through the tiles, one thing that we are missing that's kind of key is, since we have that 17th row of vertices, the 17th row also lines up with the first row of the next tile over, right? So that vertex data actually needs to be the same. And so we weren't doing that before, and that was causing some of our problems as well. And so what this does is it basically tries to take that into account for everything except the left and topmost terrain chunks, right? And so we go ahead and grab that previous data and mirror that over to the next set, right? And that just kind of corrects that issue. And then here there's some variable renaming. We also applied scale to the vertex position height, so that scales along with the rest of the terrain. And I think the rest of this stuff is really just indexing changes, right? So that's where the primary number of issues were, right? So this is all index changing all the way down from here, right? So I'm not going to go through all those things individually. Doesn't really make sense, right? We have the final algorithm for this is actually going to be in the sort of next set of changes that we'll take a look at anyways, because we cleaned it up a little bit even beyond this. And this is all basically just code that was moved elsewhere further up. We've moved that here. So that's what all this stuff isn't truly deleted, it's just moved. Here's the header file. So a couple changes that we made in the terrain chunk itself is each terrain chunk now has a generation so that we can tell whether or not that terrain chunk has been loaded. And then we have the center and the extents as well as the material stored on each chunk individually. The terrain itself also has a generation for every time it's reloaded or changed. That'll be important when we have a terrain editor for knowing when we need to re-upload geometry. And that is pretty much it for at least for that particular commit. The second one here is mostly everything else surrounding that, right? So I just added some stuff here to the change log that wasn't actually added when I committed before on the last stream. So it wasn't truly all pushed up. I noticed that sort of after the fact. So we already talked about the renderer mode wireframe and all that stuff. That's all been previously fixed, right? And that's mostly what we're dealing with here. So we also split out in our to-do list, we split out LOD and tessellation to separate tasks. So LOD is done, tessellation is a future item. This blending between LOD levels gets marked off later. In our terrain shader, we have a wireframe mode. That's just the support for that. I think we've already been over that as well. And so most of what's in here is actually just support for that wireframe chunk of code, right? Or logic, rather. We've also gone over the LOD view from position. We've already touched on that. So I think we're pretty much, like, most of this stuff is actually stuff we've already talked about, just wasn't changed or checked in before. So that's those two. And then the next one is render performance buffer uploads. So this is a little bit, I could have technically done this at a different time, but I didn't want to merge in this branch and then do it separately against, you know, the 0.6 version branch. So I decided to go ahead and tackle it in here, and I'll briefly discuss what that is, and then we'll take a look at that. Let me see really quickly. So, in chat, hey, I always love these streams. You've really helped me understand graphics programming. Awesome. I'm glad to hear that. What are the next big ticket items? Any updates on the secret game idea? So we will talk about that. The first part. The second part, not yet. Just because we're not quite there yet, right? We actually need to do a stability pass on the engine. There's a few things that I've noticed that are a little bit fragile that we should probably tighten up and lock some things down and maybe do some further performance enhancements and stuff like that before we get to adding too much in the way of new features. But we are going to add some stuff tonight, right? So let's see. I think that's it. Yeah, for now. Okay, cool. All right, so performance and buffer uploads. So I guess before I jump into that, let me take a quick minute and just kind of talk about what I mentioned or alluded to at the beginning of the stream. So today is a little bit of a bittersweet day. So there's some really cool things that happened, and then a not so cool thing that happened. So these are our current stats over on Twitch and YouTube, right? So we hit 2 major milestones today. We hit 1,000 followers on Twitch, which is absolutely awesome. It's taken us a year to get there, and I think that's really incredible, right? So thank you guys for that. I really appreciate that. And also on the YouTube side, we actually surpassed 13,000 subscribers. So that's another big milestone. So I appreciate each and every one of you guys for that. Thank you for that. So yeah, that is the first part of it. And then I'll answer this chat real quick, and then we'll get back to the other thing. Hey, are you the Travis VV from the Kohi Minecraft server years ago? No, I am not. But that's hilarious because I actually have seen like the Kohi like Minecraft server stuff when I searched for Kohi, but I didn't know the dev's name was also Travis. That's hysterical. And was his last name like literally starting with a V as well? That's nuts if that's the case. I have seen that pop up, like when I just do Google searches for Kohi just to see what comes up. I do that every once in a while. But yeah, that's super funny. But yeah, no, I'm not that same person. No. All right. So yeah, we hit some pretty cool milestones here. And then the other not so cool thing, and this is why I've been sort of avoiding questions as to how I am, is I found out today that I am getting laid off, which is something that is happening across the tech industry for a couple years now, honestly. And it bit me today, and it sucks. But, it is what it is. We're going to pick up and keep moving on, and, I'll dust myself off and get back up on my feet and get going, right? And so the reason I mention that here is because you'll probably see me posting about it on Twitter and stuff like that, just because I need to find new work. So obviously, if you guys know of anything that out there that's available, I'm always listening and interested, right? But as of right now, I'm getting laid off, which is not great. So that's my day job, obviously. So this has been sort of a hobby of mine that I've been doing sort of on the side. And that's just, it's still going to be that, but I may wind up having a little bit more availability here, at least in the short term, while I look for new work. Right? So, that's a thing. So I appreciate the support and you guys being here for sure. Are you planning on going to the game dev industry now? So, I don't know yet, right? I'm still processing it. But what I do know is, there's obviously bills and stuff to pay. So I'm basically going to take what I can get, right? I'm going to look for work doing whatever it is that I need to do to make that happen. And if it happens to be game dev, cool. But more than likely, probably not. If for no other reason, typically because there's been lots of layoffs in that industry lately as well. And the pay doesn't tend to be as high as working outside the game industry, right? Which is why I sort of stepped away from it for a little bit, a few years back, right? So more than likely not unless something awesome comes along, right? I'm open to just about anything in terms of that, but, I have to be realistic about it too. So, let's see. Sorry to hear that. Lost my job 4 months ago. Non-tech for me. That conversation always sucks. Yes, it does. Yeah. I got a meeting on my calendar that kind of popped up last minute that was like, yearly review. And I'm like, that's weird. It kind of popped up. And then as soon as I dialed into the meeting and HR was there, I'm like, I'm getting let go, aren't I? I just knew. You can always tell when HR is in there what's going to happen, right? But yeah, I'm sorry to hear that, and I hope that you've recovered from that on your side as well. So, yeah, for right now, it's got to be something that's remote for me right now. Relocation's not an option. I actually just moved 2 years ago, so unless it's something that's crazy good, and obviously that would have to be a discussion, right? Because I can't just uproot my family, right? So there's that. There's lots of complication that goes into that as well, right? So, but yeah, that was sort of the bittersweet bit of that I was talking about, right? So, anyway, moving on from that. So I'm really happy that this has gotten to this point. It's definitely not large enough for me to do it full time, but maybe one day, right? Anyway, so let's see. Let's take a look at the performance stuff that I did in terms of buffer uploads. And this was actually something that was directly impacting frame rate. So, hey Taman, how's it going? Good to see you. So basically what we, how am I doing? I'm all right. Yeah, I just kind of covered that a few minutes ago, but yeah, I wound up getting, I found out I'm getting laid off today, so not great, right? It is what it is though. So I'm still going to keep moving forward and keep working on this while I'm looking for work, right? Yeah, there's that. I don't tune into many live streams because of the time zone, but I check out most VODs on YouTube. I appreciate that, Omniscient. I appreciate that. Yeah, I know the time frame is a little bit weird for a lot of people, and it's something I wish I could change, right? But having a full-time job, although now that might not be as much of a thing, at least in the short term, right? Hopefully very short term. But yeah, maybe we'll be able to do something about that eventually, right? Yeah, I think I'll find something soon. It is what it is. Thankfully, my wife is still employed, right? So we're not completely screwed, right? But with your diverse skill set, I have no doubt you'll spring back quickly. That's the plan, right? As quick as possible, anyway, right? I know those things take time, so yeah, just putting out feelers and stuff at the moment. But yeah, streaming may get temporary increase in number and frequency, right? Maybe, we'll see. But yeah, all right. So performance. So one thing that we were doing was there were a lot of places where we were doing updates on vertex and index buffers, usually vertex buffers, every frame. So this would be things like, or every frame or nearly every frame, right? So the little wireframe boxes that would move back and forth, those were getting updated every frame. And then we also had the text that would get regenerated and updated almost every frame, right? We had lots of these things that were sort of happening in that manner. And for anything that's the vertex or index buffer uploads there, we're making use of a staging buffer. And that staging buffer was basically using a single user command buffer and waiting on the device and or queue to become idle, and then filling up that command buffer with commands and firing it off to be executed in the queue. And the overhead of doing all that every single time was actually greater than the amount of time it took to execute the tasks at hand, right? And so what came of that was basically we were doing, depending on what was being updated per frame, it was anywhere between, I think it was 4 and like 10 of those per frame. And that's a lot of stalls to have per frame, right? And there was basically a gigantic amount of time where we were doing nothing on the CPU and nothing on the GPU because we were stalling, waiting for those queues to become available and run the work. So what we've done is we slightly changed the renderer loop to have a sort of prepare frame section where we could take any of that work that needed to be done, and at the beginning of the next frame, before we start drawing things, before we begin render passes or anything like that, we would jam that work into that queue, do that first, and then draw the next frame, right? And that's because we don't really have multi-threading yet. That's kind of how we're doing it, right? And so that is essentially what we've done here. So what we've done is we have essentially these new functions everywhere, including the standard UI and things like that are these frame prepare functions, which is optional. But for anything that has an update like that, we say, okay, let's regenerate the new geometry during the frame. That's fine. And get everything ready to go. But hold off on the actual update or upload to the GPU until the beginning of the next frame, and then we'll do it then. Because it's a lot more efficient to do it all in one big batch and just push all that up than to do it in bits like we are doing. So I've changed this in most places that we're using buffers to upload data, with the exception of uploading the initial upload on geometry and terrain, things like that, right? And so that is basically what this is doing, more or less. It's the Cliff Notes version of it, right? I also went through here and added some stuff to the to-do. So this is some stuff that I have in mind that we need to actually handle. So I wanted to get it written down so that we don't actually miss it, right? And so we want adjustable global scene properties. These are properties that we could set ideally in the console to be able to adjust stuff on the fly, right? And get rid of some of those hard-coded items in our shaders. We also want per scene vertex and index buffers. And this is so we can have multiple scenes running at once, but each one can have its own vertex and index buffer. Right now, there's sort of a global one for the renderer, and that's not great, right? Really, each scene should probably have its own. So we want that. And then the standard UI probably will have its own as well. And then we want to queue up the data uploads during the scene load. So basically the way that this works right now is we are also doing all this back and forth with uploading of data. So we say load up the mesh data, for example, off of disk. And then as soon as we're done loading that, go ahead and upload that to the GPU. And then load the next one and upload that to the GPU, and the next one and upload that to the GPU. That, of course, creates a lot more waits, a lot more time that's sort of not being spent wisely, right? And so we need to come up with a system of like queuing up those uploads of the of all that data and then pushing it up to the GPU in huge batches, right? Instead of sort of doing it piecemeal. And then on top of that, multi-threading it so that we can do that on a different thread and not hold up our actual drawing of our frames, right? And so that is a big one. And this is just some steps that I was thinking of doing in terms of like detailing out the spec for it, right? And then we also want some adjustable directional light properties. We're going to take a look at some of this stuff tonight. So things like max shadow distance and fade distance, cascade split multipliers, and shadow mode. So like soft and hard shadows or no shadows. And then we also want to eventually get percentage closer soft shadows. So that's like the closer that you are to the surface, the sharper the shadow is, and the farther out you are away from it, it softens a little bit, right? We want to get that in there as well. And then I have a couple of other items here of things that I want to do, and this is part of the maintenance pass that I want to do, where we split off some of the core items to sort of like a core or foundational library of its own. so that they could be used without having to pull in the whole engine. So that would be things like our defines H that contains our types that we use for everything, our memory allocation functions, things like that, strings, containers, all that kind of thing, right? And then we want to split off the platform layers into separate libraries outside of the engine as well, just so that those are a little bit more plug and play, and we don't have so much define type of stuff going on in our core engine code, right? So we want to get some of that out there and make it a little bit more modular. All right, so before I move on to this, we are going to have ads here in just a second. So, Tammin, do you have Java experience? I wonder. Not formally. No, I've used it informally for like side projects and stuff, but I've not ever used it like professionally. But I've used C# and that's pretty close, right? Java's not a huge leap away from that. Roberto, thanks for the heart. Appreciate that, buddy. Sam Davis, how's it going? Good to see you. And we have ads. So for those of you who are new to the stream on either side, so every 30 minutes on the Twitch side, we get served with 90 seconds of ads. There's not really a way to avoid that. So what I do is I like to pause the stream so that nobody misses any content on either side, right? And so I know YouTube ads work a little bit differently over there, but on the Twitch side, we're served, I should say, up to 90 seconds worth of ads every 30 minutes. So depending on region or locale, you might get, say, 30 seconds of ads or 10 seconds of ads or no ads at all, right? But we like to just pause the stream so that nobody misses anything, so that anybody that is getting that full string of ads doesn't miss stuff, right? Also gives me a chance to hydrate. So we got about 20 seconds left on ads, and then we'll continue. A few more seconds. All right, and ads are dead. Awesome, I will keep an eye out for that. And Tammin, if you, for some reason, the DM doesn't work, just ping me on the Discord server, and I'll take a look there, right? And I'll DM you if it doesn't work towards me for some reason. If you can do C#, you can do Java with Google handy. Yeah, exactly. I mean, the syntax is very, very similar. So, yeah. And I've used it enough to be, in a couple of days of using it, I would be up to speed on it. It's more like, what's the library function to do this, right? Versus the C# version of that. That's all. That's really the only kind of thing I would run into with that, right? Okay, so this change set to the engine core is basically indicative of everything else that's changed, further down. So this basically is probably the best description of it that I have. So one thing that we've added as well to the renderer is this ability to begin a debug label. And so we've seen this in RenderDoc when we capture a frame in RenderDoc, how we have the sort of color-coded sections for the render passes over to the left. This just allows us to, we've exposed that functionality basically to be able to do that from anywhere within code, right? So we now have one that's called prepare frame that shows up in yellow. So it starts here and ends here. And basically what this does is we count everything in the systems manager render frame prepare, right? So this is basically what passes the frame prepare all the way down to all of our subsystems. They can opt into it. It's optional. So if they need to do something in the frame prepare phase, they can. So it's that, and then the applications prepare frame as well, right? And that's just wrapped up in a debug label so that we see all those commands there. The other thing is we removed renderer begin and renderer end to the engine. The reason for this is because this is what actually kicks off the command buffer, which we need to actually perform all of these things, right? So for the new lifecycle, we've actually moved this here and here. We may wind up having to tweak this or move it around a little bit more, but for right now, this is basically kind of what we're dealing with, right? So that's for the main render loop there, and then we've also taken present out of the application, and we have moved it back to the engine because the application shouldn't really have to care about presentation, right? So that is that. Apotham7787, thank you so much for the tier 1 sub. I really appreciate the support there. Thank you. Appreciate that. Singyi, hello. Good to see you. Let's see. Hey, should I learn C or C++ in 2024? Is C getting replaced soon? So C is not getting replaced anytime soon. I'll put it that way. Operating systems are still written in C. Embedded code is still written in C. Like it's not going anywhere anytime soon, right? The answer I usually give to this is really you should base it off of what you're wanting to do, right? And pick the language for what you want to actually do. A lot of game development uses C++. That being said, I also think it's really important to understand C before understanding C++ if you don't understand either one. And the reason for that is because C++ builds on top of C. So if you have a really solid grasp on C, it's going to set you up really nicely to be able to use C++. Because there's a lot going on in C++ that you're just not going to fully grasp what's going on under the hood unless you understand C. And, C++ has become a very large, complicated language, especially, the latest versions of it. And so, C is a much simpler language. So I would say under a lot of circumstances, if you have the time, I would say C first and then C++. I would learn both because you can literally build your C++ skills on top of your C skills, right? So that's what I would say there. Okay, so that's that. And then most of these other changes are reflective of the changes that we saw in the engine. So I'm actually not going to step through them one by one. I'll just kind of hit the highlights, right? Our systems manager goes through each one of the systems and adds and calls this new function pointer for render prepare frame if it exists for that system, right? So we have a new type def for that. And then when we register a new system, if it's provided, we assign it, right? There's also a new parameter that's in systems manager register. So that's just that additional function pointer. You can see that we're passing null for most of those things. The only one that we're not passing null on is the system UI, right? Or the standard UI system, rather. And that's actually included from the test bed, so you won't see it here. Systems manager, here's just the new header function right here with all the comments in that. Geometry utils, we have this 9-slice render frame prepare. So this was one of those updates, right? Before we had this update 9-slice that sort of regenerated all of the vertex data and then did a vertex update, which updates to the GPU. Now what we do is we have a dirty flag and we mark that dirty flag, and then we can call prepare frame and say, hey, if we don't have a 9-slice, return. If we do have a 9-slice that's dirty, go ahead and upload that vertex data to the GPU and then flip the dirty flag back off. And you'll see that pattern a few more times throughout the code base. So that's the header file for that. The renderer front end, here's the debug label, begin and end. That just passes through to the back end. That'll make sense, of course, when you see it. And then, let's see. Most of these changes actually have to do with a change to render buffer load range, which basically is a true or false as to whether or not to include in the frame workload. So what that means is, do we take this workload that's being done here and do we include it in the beginning of a frame and use that currently open command buffer to record to, or do we set up a one-time use one and use that instead? And so all of these function calls here are all changing to just include that, right? So you can see some of them are true, some of them are false, depending on what we're doing. The renderer front end, this is just the header file, right? We've already sort of been over that. The other thing that I did in render types is we have the ability to turn off validation in Vulkan, right? Because if we are trying to sort of get an idea on performance, validation really slows that down a lot. And so we have a flag in here to actually turn that off. That is not dependent on it being a debug build. So we can very easily turn that off now. The back end obviously has these begin and end debug labels. And then, of course, we have these include and frame workload for all of these function pointers to the back end. And then all of the debug shapes also hold off on their geometry updates and have a dirty flag. So those follow the same pattern. So I'm not going to go over those because we've already kind of been over that. That's the same thing. That's also the same thing. So is that. Okay. Terrain is basically just an update to include that additional include in workload. Terrains, we're not doing that right now, so that's false. SUI button has the prepare frame, right? So that's, again, just offloading that workload. SUI label is the same thing. We just offload the workload, right? So this is just all logic to support that change. And then, let's see. SUI label, that's the header file. Panel, same thing, because we can resize a panel, right? So we might need to upload that. So again, we have a dirty flag. We offload that work. Here's the one for the standard UI system, right? So the standard UI actually has this prepare frame, right? It utilizes that, and all it does is go through each of the individual controls and says, hey, if it has the render prepare, call it. All right. Editor Gizmo also is kind of the same thing because it has changes when we hover over it and we actually change the vertex colors and stuff like that. We need to actually go ahead and change that out. So again, we just offload that work. So that's most of what this change set is, right? We also did away with the present clock because it doesn't make sense to have since we no longer present within the application, right? Here's the simple scene render frame prepare, right? So this just doles out the work of all the debug objects that we have there. And then testbed main is mostly just function call updates. We also increased the draw distance of the camera a little bit. We got rid of the present clock timer, so that's all that stuff. Got rid of it out of there. Here's our calls to like our frame prepares for our editor gizmo and our simple scene. Here's where we remove the logic for the renderer begin, renderer end, and the clock stuff. So we've removed all that. And then the Vulkan renderer now has its own changelog, right? So we've detailed everything that we just went over for that. And that is going to be updated to 0.4 now from 0.3. And the reason I did this is because we're going to be adding features to this as a separate thing. So I've started to track those separately. I'm just going to finish stepping through this and then I'll get to the comments because I see there's some over here in a minute. And I'll just, I'll get to those in just a second. So the Vulkan backend is basically reflective of all the changes we made on the front end, right? So we store whether or not validation is enabled. And then instead of hiding that behind a debug, we put it within a Boolean check, right? So that's changeable when you're booting up. It's not changeable during runtime. It's either going to be there or not there when you create the Vulkan instance, but yeah. So there's that. Here is the begin and end debug label. So this is the exact same thing we were using in render passes. It's just we've moved that logic here and gotten rid of the hard-coded version that was in the render passes. So that was here, right? We had this render pass begin and we were doing it in line. Now we just call out to this function and this function. More uploads or upload changes, including in the frame workload. That's all this stuff is. And so the backend change to that is in this copy range internal. What we do is instead of doing this queue wait idle and then begin and allocate and begin single use, right? For a command buffer, instead of doing that, we say, okay, we have a pointer to a command buffer, and then based on this, we choose which one we're going to use. So if we're not including it in the frame workload, then we will wait for the queue to be idle, we'll create that single use, and we'll assign the command buffer to that temp command buffer, right? Otherwise, we'll just go ahead and grab the currently, it should have already been recording graphics command buffer for the given image index, right? And then here, instead of temp command buffer, we just use whichever command buffer we selected. And then here, if we are not including the frame in the workload, we just need to end that single use buffer, right? And that's really what powers that entire change. It's not a lot, but it allows us a lot of flexibility in how it runs. Let's see. So these are all function pointer updates. Validation enabled, we store that in the Vulkan context now. And then function pointer updates. And then the version updates of the Vulkan renderer, right? And that's that change set. So I know that's a lot. It looks like a lot of code. I mean, I guess it is a lot of code, but when you think about it logically, it's actually not that crazy amount of stuff, right? Let's see. Let me check on chat here. All right, so sees the path some to ability some consider unnatural. Yeah, that's not entirely inaccurate, Taman, for sure. C++ is basically object-oriented C, exactly. They call it C with classes, was the original name for it, right? If you've already got a strong understanding of OOP, then jump straight into C++. Otherwise, I'd say start with C. Yeah, and that's fair, right? However, I would say whether or not you have familiarity with OOP, right? And even if you choose to learn C++ first, still learn C, right? And use it for a little bit, right? Because it helps you really understand the internals of why C is the way it is. And some of the things that happen under the hood that C abstracts away from you, right? Like automatic pointers and stuff like that. Apotham, in my opinion, you should never learn C++. Then again, I really hate OOP and how they just shove everything in there without considering if it's good for the language or not. I 100% agree with that. Yeah. I learned C++ first, so I kind of did it backwards. But yeah, I'm not a fan of OOP. I use it, for work where I have to, but in my own code, if I don't have to use it, unless it makes sense to use it, because there are times where it makes sense. But yeah, usually I try to avoid it, right? You think you'd start with C? Yeah, I would agree with that. Or C style C++, right? If I use C++, that's usually what I use. OOP is a tool. The problem comes with people hitting nails with pliers. Yeah, exactly. So people try to apply OOP to everything, which is the mistake, right? Because OOP has lots of problems that it causes instead of solves, right? I did C style C++ for about 10 years, and then I woke up one morning and just decided to use C. Yeah, that was basically me, too. Yep. I called it C++ Lite. Yeah, that was basically, I had the same epiphany. You're a savage. Yeah, I mean, I guess that makes me a savage too, right? I think the problem is the object orientation. Objects are useful, but you shouldn't use them every time. Yes, exactly. You hit the nail right on the head. Yeah. It's a tool just like anything else, but there's how does that expression go? When you have a hammer in your hand, everything looks like a nail, right? And that's how I feel that that OOP is treated, right? People try to apply OOP to everything because that's what they think about. But object-oriented programming is not the answer to everything. More often than not, I would argue it isn't. Causes more problems. Exactly this. Yeah, exactly. So, cool. So the last one, and this change set is considerably smaller, right? All we did was took all this repetitive crap, basically, and cleaned it up, right? So we put in a terrain skirt side enumeration here so that we don't have hard-coded magic numbers in there with just left, right, top, and bottom. And that happens to be the order that we are doing things here. Left, right, top, and bottom, right? And so if we look here, now this is all compressed into a nice loop. We do have this, which I'm not huge on, but I couldn't think of a better way at the time to actually do it. And it's still way more condensed than this, right? So I'm happy with it. I'll take it for now. So we did that there. And then within the indices or index part of that, we kind of did the same thing, right? So the surface indices were one thing, but then we had all of this repeated code for, left, right, top, and bottom, right? And that's all been condensed into a single loop. So this is like the first half of it where we branch off of which side we're on to do our indexing. And then the bottom half of it is pretty much all the same with the exception of winding order being different on two of the sides, right? And so that with that, that's like everything completely cleaned up and done as far as I'm willing to say for right now. Taman, are you from Brazil? I saw your neck end. Yeah, he is from Brazil, actually. Yep. Okay, so I think what I'm going to do is I actually have some pending changes locally that I wanted to talk about as well. I suppose I could push those up to this branch and then just merge the whole thing. I suppose that makes sense. Maybe we'll just do that. We'll take a look at that. So what I wanted to talk about tonight was shader hot reloading, right? Because this kind of ties up what we were doing with terrain LODs and stuff like that. And that's all working well. We'll run here in a second and show you that. In fact, I could probably just do that now. There are a few things that I've come up with my changes that I probably am going to need to fix. But, all right. So, what we have is if we go to our wireframe mode, we actually have all of our geometry sorted out, right? So we can see now that we have all of our skirt geometry all the way around generating correctly on all four sides, right? And so if I go up here and we take a look at what is actually happening, if you look at the geometry that's down here, it's a heck of a lot more dense than what's back here, right? And I don't even think back here is this isn't even the minimum level of detail, right? We actually have to back up a little bit more to see some of that. I think there's one more. Yeah, there it is right there, right? So eventually the terrain chunk will become one quad, right? So it starts off as 16 and then it drops down to 8, which I think is actually, yeah, this is 16 right here. It's a little hard to sort of get it all on the screen at the same time, right? Because this is basically the maximum range we have. But we can see that these couple down here, because of their proximity to the camera, are 16. These are all 8s, right? These are 4s throughout here. And then these are 2x2. And then that one back there is 1, right? So we have all of our level of detail stuff working correctly. Cry, you're from Portugal? Awesome. It's pretty late over there for you then, isn't it? You're Gradually dominating my stream, yeah. I would ask that you guys only use English though, right? Because I don't understand Portuguese, unfortunately. So yeah, if you guys could stick to English in the chat, I would appreciate it, because you guys could be cursing me out for all I know, and I have no idea. I don't think you would, but I still remember the first time I saw hot reloading in action. It blew my mind. I just stared at the screen for about 5 minutes. Yeah, same thing, right? And our library code is technically hot reloadable. I did discover while I was experimenting with it offline that we have a couple of things that I broke over the last several streams that we need to fix to get that to work again. But yeah, our game code or our application code is hot reloadable as well. Oh, he thought he was the only Brazilian here. No, I think it's 14% of my viewers here and on YouTube are actually Brazilian. It's actually a pretty big number. So yeah, when we actually get ready to make and release games, regional pricing is definitely going to be a thing. There's another Brazilian that sometimes shows up in here. I gotcha. I appreciate you translating that for me. Thank you. Yeah, I figured that's who you were talking about. Yeah. I think he was here last stream. He usually tends to show up a little bit later. Yeah, Cry, I see what you mean, yeah. It's 2:39 a.m. over there. Ouch. You mentioned it because one of your viewers is Brazil, so we share the same language. Yeah. I would imagine that the dialect between Brazilian Portuguese and Portugal Portuguese is quite different. But yeah. It's kind of like Mexican Spanish versus Cuban Spanish. Very different. Versus, Spain Spanish. Oh, Apotham, you're not Brazilian, but your wife is? That's awesome. Like I said, there's lots of Brazilians here. It's pretty cool. I like Brazilians. Nice people. All right. So, a couple things that I wanted to cover while I actually still have this running. Rock Derek, thank you for the follow. Appreciate that. Welcome. So if we go back to our regular rendering mode, right, and we just zoom in a little bit. One thing I kind of wanted to cover is kind of our shadow mapping and some things that we need to kind of look at and fix and adjust on that, right? So we have our cascade view. Oops, wrong one. It's 3, right? So we have our cascade view and we have these working. That's all great, right? But we don't really need terrain or shadows rather that extend across the whole scene, right? It's kind of overkill. And in fact, we've actually adjusted a little bit our cascades, right? So you'll notice back there is white, which is sort of beyond where the cascades reach, because we've made some adjustments. So if I just move this down a little bit further, we can see basically all 5 zones, if you will. And so this red is basically the closest cascade. Then we have green, then we have blue, then we have yellow. And then anything that's white is beyond the scope of where our shadows are. And the reason that we've done that is because we don't necessarily need our shadows to stretch quite as far. And so if we take a look at the shadows as we move away, and it may be a little bit difficult to see because of how far away it is, but we can adjust this, right? If we watch as this white line comes across, look at what begins to happen here. We fade out, right? And so this is kind of the pending changes that I have, where I've been kind of looking at how to make that nicely kind of occur, right? So what I wanted to avoid was basically having the shadows just sort of hard cut off in the distance and not have anything, to sort of smooth that out, right? And so as we get close to the end of the last cascade, we start to fade the shadows out. So what this actually is we have a new parameter that's basically shadow distance, and then we have a shadow fade distance that we use to generate how far out this is. Let's see. Dino Dinny Nugget. I hope I pronounced that correct. With a raiding party of 12. Thank you so much for the raid. I really appreciate that. Welcome, raiders. What are you up to tonight? What were you streaming? Hey, Trash Can. How's it going? I hope your stream went well, by the way, Dino. I'm going to toss you a follow and give you a shout out real quick. Game Engine and C++. All right, I'm glad I followed you. Love it. How far along are you? You achieved the teapot? Nice. That's awesome. I know exactly what you mean because I actually have used the teapot mesh as my test mesh for a lot of engines over the years. So, tends to be a good test case, right? All right, so Utah teapot imported. Oh no, we have ads. Let me see, can I swat them away? Nope, I can't. All right. So, unfortunately, we have hit ads right as you guys are rating. So, what I usually do is I pause the stream so that nobody misses content. And so that is what I'm going to do this time, and then I'll give a introduction as to what we're doing here and whatnot. So if you guys can just bear with me during the ad break so that nobody misses anything, I will go ahead and get right to that as soon as we get back from the ad break. I wish I saw it, unfortunately, but it is sometimes the way it works. Have a good stream. You have to go. Okay. I appreciate the raid, Dino. Thank you. Is it Dino or Dino? I hope I'm pronouncing that correctly. I guess I'll find out. I'm gonna keep an eye out for your stream, and I'll catch you next time for sure. So let's see. We got about 30 seconds on ads. I'm just gonna hydrate really quickly, and then we'll get into the intro. Just a few more seconds on ads, and then we'll continue, okay? All right, and I think ads are dead. Cool. All right, so what we are making here is called the Kohi Game Engine. I went ahead and dropped a link into both Twitch and YouTube chats. We are simulcasting, so we're live on both. So what we're basically doing here is we're building, a game engine almost completely from scratch. And I say almost because there are a couple of small utilities that we're using. But it's like 99.9% from scratch, right? And we're doing the entire thing on camera. So it started off as a YouTube series, changed formats a few times over there, and then last year we actually began streaming on Twitch, streaming development on Twitch, and then putting those VODs up on YouTube, and now we stream to both, right? And so essentially, what this engine is it's a free and open source game engine. It's Apache 2.0 license, which means that you can use the code however you see fit. And the only thing that you have to do is just, if you use it, you just say, hey, I used Kohi, and that's it. That's literally it. There will never be any sort of fees, royalties, licensing fees or anything like that. It's 100% free. All the streams, all the content on the YouTube channel, none of that is paywalled. It's all 100% free. We're doing this as an educational resource to show a way of building a game engine from the ground up, right? And we literally do that, including we have our own build process that we build from scratch as well. And so we're doing that as a way to show, a way to build a game engine. Of course, it's not the only way to build a game engine. And in some cases, because it's educational, it might not necessarily be the right way to do it. but it's the way that we do it to explain things, right? And then we go back later and we refactor stuff, right? And so that is kind of what we're doing. All of the code is available here on GitHub. It's completely open source, like I said. And we have documentation and all that stuff as well. So we also do have API documentation that's auto-generated using Doxygen. So that's available as well. So the example that I like to use is this guy, right? So we have all of that documentation here as well. And we also have a more or less of a roadmap just to kind of show you guys where we're at. We are currently working in the feature branch that is a terrain chunk, and that's about to go into the 060 feature branch. So if I take a look at this guy, and we take a look at the, where is it? The to-do list. This is basically our roadmap at this point. So we've got a listing here of all of the features that we've done, as well as the ones that are still needing done. So everything with a check is done. Everything not checked still needs doing, right? But we have quite an extensive list of features here of things that we've worked on and talked about over the course of this, right? So the idea behind this is that the engine is built in a modular fashion. So the whole thing is basically that there's very few things that are part of the engine's core. A lot of things are implemented as plugins, and that makes it very extensible, as well as very customizable. So an application that utilizes the engine can choose the different components it wants. So the first rendering backend that we're using is Vulkan. We are eventually going to have Direct 3D, and we are eventually going to have Metal, and probably OpenGL as well, maybe. And so those things are all plugins, for example. The audio system is a plugin. We might eventually have an ECS, but it'll be completely optional as a plugin. The UI system that comes with this is a plugin as well, right? And so we're building everything, all these different pieces, and the application can kind of decide how it wants to put those things together and use them. We also are cross-platform, so we support Windows, Mac OS, and Linux desktop platforms, with the eventuality of supporting iOS and Android in the future. Okay, I hope that all makes sense. This is an interactive stream, by the way, so if you guys have any questions, feel free to jump into chat. I do keep an eye on it, and now that I'm done on my soapbox, I'm going to catch up on chat. And then I'll kind of talk about where we are, right? It's looking good today. Yeah, it is. It's coming along, right? Let's see. By the way, when it comes to descriptors, do you use one descriptor set for a buffer or a descriptor set with multiple bindings? So right now we have a descriptor set with multiple bindings, right? So we really have, per shader, we have 2 descriptor sets, or I should say a maximum of 2 descriptor sets. So we have a descriptor set for global values, right? So that would be things like your projection matrix, your view matrix, things like that. Things that are more globalish in scope. So there's a single binding within that encapsulates all of the different uniforms that we have. So that's sort of our uniform buffer, right? And then we have a binding per sampler, right? And per sampler could also be an array of samplers as well, right? So we support array types and all of that stuff. We have some metadata that we use to tell our engine how to set all that stuff up. So we have one of those for globals, and then we also have one of those for instance. And the instance is, you can think of it as like a material instance. So in a large scene, you might have let's say a wood material and a metal material, right? And you have one instance of each one of those, right? It's a material that is set up to look like wood and a material that's set up to look like metal. And then you have multiple objects that use those things. And those individual scopes for those individual per object levels called locals, and that uses push constants for right now, right? At least as far as Vulkan's concerned. So globals and instances both use a descriptor set. You can have a shader that doesn't have globals, and you can have a shader that doesn't have instance, right? And you can have one that doesn't have samplers or does have samplers on either case, or you can have one that has uniform buffer variables or doesn't, right? So, yeah, it took us a few iterations to get to that point, but I'm pretty happy with where it is now. You were struggling a lot with the descriptor set layout and so on. Yeah, it's a lot to get your head around, right? Bindless is your friend. Descriptor management is one of the hardest things in modern APIs. Yes and no about the bindless, right? So the reason we haven't gone bindless is because there's a lot of hardware that doesn't support it, right? A lot of implementations don't support it. And so I would have to write this logic to handle descriptors anyway. So why not just roll with that, right? We might eventually do bindless, but that's only ever going to be used by hardware that supports it. It's not required by the Vulkan core, so it could be not supported. So I just didn't see this as the point in doing all of that work and then also having to do it the other way, right? Let's see. For the audio, do you use the closed source version of OpenAL or OpenAL soft? So they're both the same API, right? So it's basically whatever you link with. So on Windows, I think I did use the closed source version of it, but on Mac and Linux, I used OpenAL soft. But the API is identical, right? So it doesn't really matter. Is OpenGL still worth doing? I just wonder how many graphics cards can do Vulkan. So that's my thing, is like, if we decide to target a platform or maybe really old graphics cards that don't support it, or maybe that don't support Vulkan the way we want it to, like maybe it only supports Vulkan 1.0 and that's a huge pain in the butt and I don't want to deal with it, then maybe I would use OpenGL for that, right? That's why I'm a little undecided, right? Because it's like, I could still do it, but I haven't really decided. Let's see. I meant you stare. Oh, okay. I hope I get to use bindless, but first of all, I want to understand how it works. Also, offsets in Vulkan seems to be kind of complicated. What do you mean by offsets? Like memory offsets? I mean, it's just more opportunity to shoot yourself in the foot more than anything, but Vulkan 1.3 is supported all the way back to the NVIDIA 700 series. Yes, but I'm thinking of other graphics cards that people are likely to have, like on laptops and stuff like that, right? With like toaster graphics cards, essentially. I'll have to take a read in Kohi's descriptor implementation, see if I can understand. VK descriptor set offsets for dynamic uniform buffers. Oh, okay. Right. It's really just offset into an array of memory, right? Is all it is, ultimately. I get lost in the range and size of VK descriptor sets. Yeah, so I feel like the way I've got that set up is probably going to make sense to you. So let me see here. I think that's Rabid Jellyfish. Appreciate the follow. And Vinny, thank you for the follow. And the stretch, I appreciate that. I need to do that for sure. Okay. Let me take a look at the YouTube side. Are these parameters designed with different values for different interpolation purposes, indicating that shadow fade distance has a lower threshold and creates interpolation in relation to the other variable? So I think what you're asking is shadow fade distance has a lower threshold. And yeah, so they're basically going to be different values for interpolation purposes, basically exactly what you're saying. So more or less, let me Let me bust out paint, right? And maybe make this, let's go dark mode on this so you guys aren't blinded. All right. So what I mean by that is essentially we have, you know, the camera over here. Actually, I'm gonna use, let me see, how do I want to do this? So let's say our view frustum looks something like this across the scene. Actually, let's increase this a little bit more. All right, so let's say our view frustum looks something like this, right? Obviously, this is not to scale, right? And so, you know, we've got some huge bunch of objects here. Like, let's say we have a terrain that goes like this, right? And then off the screen, who cares, right? So we've got this huge terrain, right? But realistically speaking, we obviously don't need shadows over here, right? But realistically, we probably don't need them like here either, right? We probably really only need them, you know, maybe say half the view distance or something like that, right? And so we have a view distance, which is basically this guy, right? So this is view distance. And then we're going to have a shadow distance, right? So that's going to be, I'll use green for that. So this is going to be the shadow distance. It will be some length away from the camera, right? This will be shadow distance, right? And then we're going to have a fade distance after that, which might be something like that, right? And that's our fade. And so what this gains us is, instead of having a hard shadow cutoff there, we interpolate the cutoff here, right? So that we sort of smoothly fade that out, right? So our algorithm, right, is basically just a, we move out to this point, right? And then we linearly just interpolate this to cut that off. And so we want these values to be settable so that we can just kind of experiment with those things. And the first thing that I did was I actually put in, I actually added shader hot reloading. So if I go ahead and just adjust this window a little bit so that we can kind of have these things next to one another and see the updates. Okay, so if we zoom this guy in and get out of cascade view, right? Let's actually look at this in the regular view. What I can now do is come over here to, this is the fragment shader for the terrain that I'm looking at currently. So we can come down and look for our fade inputs, right? And right now I've got these hard-coded in the shader just to kind of stretch, to sort of test these out and stretch and squash these different values to see what works and what doesn't. And then I've got a to-do here, obviously, that, you know, we need to obviously treat these as uniforms. So essentially what I'm going to do here is I'll set our fade start to something smaller, like 20, right? And then I'll set our fade distance to like 2. And when I go ahead and write this and move the camera back, we can now see that fade happening, right? I didn't have the camera back far enough, but if I were to change this fade distance to, let's say 5, and save it, you immediately see the change here, right? And so we can kind of play around with the shader and update it, and it'll continue to refresh here. And so basically the way that that's working is I have file watchers on each one of the shader's raw input files. And then anytime that file gets written to and the timestamp on the file changes, we go ahead and trigger a reload for the whole shader, rebuild the pipelines and all that stuff. And then when all that stuff is loaded, we go ahead and swap it out in the renderer, right? So this allows us to really quickly kind of prototype stuff, right? So if we wanted a more hard cutoff, we could say replace this with a 1, right? And it gives us a little bit, it's still kind of, fades out, but right, you could literally put like, I guess let's try 0, right? If we wanted a really, really hard cutoff, right? And then we get this almost, pixel perfect kind of cutoff, right? The one caveat to this is that we do have a really small value being added to the fade distance to avoid a divide by 0, because our algorithm actually does some division in here, right? So what we do is we basically take we have the fade start, which is the fade distance, right? That's the distance from the camera where we start the fade. Then we have the fade distance itself. We take those two, add them together. That's our fade end. And then we do a Z clamp, right, on the Z axis. That's sort of going out from the camera. And we get the length of the difference between the view position and the fragment position, right? And then we clamp that to the fade start and the fade end. And that is how we get that value. And then we linearly sort of interpolate that between that Z clamp between the fade end and the fade start. And then the shadow, we then do a 1.0 minus the fade factor, which inverts that value essentially. And we take that, we add the shadow value to that, which would have been a 1 or a 0, depending on whether or not we're in shadow, according to the shadow map. And we basically apply that fade factor rather, and then clamp that between 0 and 1, and we have our shadow that gets applied. And that's it, right? So it just looks a lot nicer, I think, right? Okay. Let's see. Did the YouTube stream die? Or can you guys still see it there? Because it looks like it's trying to load on my side. YouTube streaming seems to be a little bit buggy lately. So I'm not sure if that's actually still up and running or not. I can't tell. Okay, time to catch up on chat. All right, so... Another Brazilian, yep. That's so funny. There's so many of you guys in chat. It's great. I love it. One more, yep. Dominating the chat. Yeah, you guys are. All good by me. You're a C++ dev studying some game engine topics in free time. That's awesome. Jarius, redeemed a pet on stream. Let me see if I have one nearby. Give me 1 second. Okay. This is the closest one. So let me switch my camera view here. There we go. Okay, so this is Pumpkin. She's my 13-year-old Japanese bobtail. Had her since she was a kitten. Rescued her from the pound. She's probably not too enthused about being up here, but she likes the scratchies, so she's putting up with it. But yeah, this is her. She's purring. I don't know if you guys can hear that. Well, she's kind of purring and kind of mad at me for picking her up. She hates being picked up, so. But yeah, that's her. I'm gonna let her go now. There you go. Soup Kitchen Games, thank you for the follow. Appreciate that. Oh, yeah, now she's mowing at me. She wants pets now. Let's see. I'm gonna have to learn Portuguese, apparently. Yeah, she's a pretty polite cat. She's also a bit of a princess for sure, but yeah, she's adorable. I love her. And I found out after I got her that Japanese bobtails are kind of a little bit rare, at least over here. And apparently very expensive as kittens, but I got her from the pound. So, yeah, that was kind of crazy. You found me through the shorts. That's awesome. That means the shorts are circulating. Well, welcome. Good to have you here. I would appreciate any spread of the word for sure. Always good to hear that you guys are finding me through the shorts, though. That's awesome. Kohi will need to support multiple languages because we're definitely going to translate the first game to Portuguese. Yes. Yep. I'm seeing that's going to be a need, right? So I'm going to have to figure out translation on that for sure. But yes, we are going to be supporting internationalization for sure. In the engine, the editor, well, I guess the core runtime doesn't need to support it, but the editor definitely will, right? And so that's definitely a topic that we're going to be covering on here as far as how we set that up. So we probably are going to set up an internationalization system that we can use for that. You have a 9-month-old calico. That's awesome. Calicos are really... Is it a male calico by chance? Because those are exceedingly rare. Females are somewhat more common, but males not so much. All right. We have our shader hot reloading working. So, we can change this, I guess, back to 3. Let's see. Let's try and find a good fade range. So one thing to bear in mind too is we also have to make some changes over on the code side to match this, right? So I've set this to 20 here, but it doesn't actually affect how our cascades work, right? So we kind of need to sync those up. So I had 200 here because I had 200 sort of hard coded over on the C side as well, right? So I'm going with 225 as our initial values. And so that'll allow us to kind of come way out here. Right, super low resolution shadows, but then eventually, when we get far enough away, we'll see that start to fade off right there. Right? So we can tighten up that fade out if we want. Right? Where it's just 5 instead of 25. I think I kind of like the 25 better though. Right? I think that's a little bit better. Oh shoot, I forgot to change the camera over. There we go. Sorry about that, guys. Yeah, still full screen. All right, cool. Appreciate that. It's a female cat. Isn't it something like 10% of calicos are male or something crazy like that? I don't even know if it's 10%, to be honest. Yeah. That's a good question. Yeah, so what I was doing was I was just sort of playing around with the values, right? So I was like, do I like 5 for the fade out of the shadow, right? Which is that, right? And I think that's a little bit too sharp. So I'm thinking the 25 is better. And I think 200 is a pretty good distance too, because if we look how far away we are from the terrain, right? And this is a relatively small terrain. 200 will stretch a decent way across the terrain, but it's not crazy, right? So what we need to do is, like I said, I've got this this value actually hard-coded in code as well. So we need to connect the two so that they're all using the same value. So that way, if I change it somewhere in one place, it changes it for everything, right? So that is basically what I'm thinking of doing at the moment. So put the 25 back in there. And I actually have... let's see. This is a number of changes that I made for the hot reloading. So we should probably go over this really quickly. This is the shader change. We've already seen that. So the core of the hot reloading is in our render shader create, right? We have this this logic that loads up the resources, right? The individual resource files, so the raw shader files. And so all we do here is we just put a watch on that file, and we say when we put a watch in the file, and then we also store the watch ID under module watch IDs, which is the new thing added to the shader. So we just store those in an array, and then whenever that file watcher goes off, we say, hey, what shader actually has this watch ID associated with that, reload that shader. So here's where the file watch is put in place. And then when we destroy, we also get rid of that watch, and now we have ads. So we'll have to wait a minute. My cat is absolutely losing her mind down here playing with a toy. It's hilarious. I guess it wound her up to be picked up. But yes, for any of you that are new to the stream, I like to pause the stream once every 30 minutes for the 90 seconds that the ads are actually running, so that nobody misses any content. And it gives me a chance to hydrate. And I know you guys over on the YouTube side don't get ads the same way that Twitch does, but I do like to just keep it, I do like to pause it anyway so that nobody misses anything, right? So we've only got about 30 seconds left. And I do see that there's some questions over there, so I'll answer those in just a second. Let's see. Yeah, we've got about 25 seconds, right? Just going to hydrate. Almost there. Okay, cool. Ads are dead. So, are you thinking about implementing ragdoll physics? So yeah, physics is going to be a conversation that we're going to have. The way I'm thinking about it is we're probably going to start off writing a very basic physics library of our own. It's not going to be anything fancy, right? And then we'll probably wind up using a third-party solution for that, because a physics library on its own can take years to write, right? And that's really outside the scope of what we're doing here, right? So implementing ragdoll physics from scratch, I don't know about that, but we probably will wind up using them, right? Have you implemented area lights by chance? Not yet, but it's something I want to add for sure. The only two light types we have right now are directional and point lights. So we have to put spotlights in as well, and area lights are also on that list. I just haven't got it in yet. But yes, to answer your question, we're going to be doing that. We just haven't done it yet. All right. So back to where we were at. So here's the destruction where we just unwatch the shader file. And then here is the render shader reload. Now, this all is registered as new code, but it's not actually all new code. So this is mostly the initial shader load code that we had where we were reading in the resource file, right? And the stage configs and all that stuff. So we read this in and store it essentially in the stage configs. And then we, here it is. There's the source, right? We So we take a copy of the source and the length now, and then we unload the text resource. And so what this allows us to do is separate the two processes, right? So we read this in, put a file watch on it, essentially, and well, I should say we put a file watch on it above, read it in, right, and then actually kick off the load. So the other thing that we do is if there is a previous copy of the source, we go ahead and free that up. And then if we, for each individual shader stage count, if any stage has an error, then we go ahead and free that up for each individual stage, so that way we're not leaking memory. And otherwise, we go ahead and we set the stage config source and source length to the new stage config source and source length. So the reason that we wait until the very end to store off all of this information is because we want to make sure that all stages compile successfully before we actually swap anything out, right? Because if it fails, like we had some bad code in a file or something like that, we don't then want to replace our shader with something that's bad, right? So we actually don't swap out the working copy until we've actually written or read a valid shader file, combined or compiled all of that into shader modules, built our pipelines, and all that stuff, right? And so what we do then is we then essentially call the shader reload, right? And that's in the plugin. And so that's where the plugin sort of just kind of does whatever work it needs to do underneath the hood to load the shader source that we pass through to it. Let's see. So here's the render shader reload for the front end. Here is the plugin interface updates for some of that stuff. Let's see. The file watch event is something that is stored in the shader system. So the shader system is what actually reacts to the file watcher saying, hey, this file's been written to. Because the shader system knows about all the shaders that have been loaded, it can loop through them and say, hey, which one of these has this file ID? Okay, one of your shader modules has been updated, you need to reload, right? And so that's basically what this is doing there. Here is where we watch for those watch events, right? The shader system has its own shader system reload for a particular shader that just passes through the renderer, right? But if we needed to do anything here, we certainly could. Let's see. The module has watch IDs. Each module has its own watch ID on the shader. There's the shader system reload exported so that we can access it from anywhere. And then, let's see. Oh, these were some fixes that I was putting in place in the testbed entry C file in order to fix some hot reload issues. It's not fully fixed yet, but this fixed some of the stuff. The other thing I did was, and I guess I can actually undo this change, is I hijacked the debug code 4 event, which was, let's see, that was turning off the audio loop file. It was turning it on and off. And I sort of hijacked that to reload the terrain shader, but I actually don't need that anymore. So I can get rid of that. Here is where in application prepare frame, we've actually set these values, right? So we need to pull these from light properties. We need to add that to light properties and pull it. So I've got some to-dos marked in there for that. And here's the shader create modules and pipelines. This is the Vulkan specific stuff that happens under the hood to create the new pipelines and stages and all that crap, right? So this is all code that existed before. It's just been moved to a different function to facilitate the reload so that we can call it more than one place, right? So that's what all this stuff is basically replacing. So instead of calling all of that in line, we now just call shader create modules and pipelines when we initially load the shader. And then when we reload the shader, we call that function again, right? And that's it, right? So it's actually not that complicated to get shader hot reloading working. All you need to do is reload the files, the source files, compile new modules, build new pipelines, and then swap those out before the next frame renders, right? So it's not that crazy to implement. Let's see. In Vulkan, do you have one pixel shader active at any given time? What do you mean by like? Do you mean fragment shader, or do you mean? What do you mean by pixel shader active at a? Yeah, I mean generally it's one at a time, right? Because you're only doing one thing at a time. Now we haven't multi-threaded yet, so we can't necessarily do that just yet, right? We haven't multi-threaded. It's all single-threaded on the renderer, anyways. We have multi-threading working in other parts of the engine, but our renderer is not multi-threaded yet. Yeah, fragment shader. Okay, yeah. We only have one active at a time right now. When we have multi-threading working, we could potentially have multiple active at a time, because ultimately, like right now, we have 4 render passes for a shadow map pass, so we could technically multi-thread that, right? And then just wait for all of them to complete and come back together. And running 4 of those at the same time would be much faster than running one at a time, right? So that's an example of. But yes, to answer your question, like right now we just have one shader active at a time, but eventually we'll have more. This task of compiling and swapping the shader can be done on a separate thread. Yes, it can. Yep. We just don't. But I found that it takes almost no time to actually like compile and stand this stuff up. So right now I'm not doing it on a separate thread, but I certainly could. Even if you main thread the renderer, you can't dispatch multiple picture shaders at the same time. Oh, multi-thread. Well, you can on different queues. Right? Yeah, if you have more than one queue, you can do that. So if you have another thread that uses another queue that was created on that thread, then you could definitely do that. We don't have that at the moment, but eventually we will. Driver might outsource shader compilation to another thread internally anyways. I'm pretty sure it does. Yeah. In NVIDIA, you only get one queue anyway. No? You mean one graphics queue? No, definitely not. If we take a look at a Vulkan info. So like this queue properties, like this queue family right here, this one has 16 alone. Multi-queue is a lie? What do you mean? I can get 16 queues out of this. They all pipe down to the same queue on NVIDIA. That might be true. That I don't know. I can't imagine why they would do that though. Maybe it uses like slices or something internally to handle it. But even if that's the case, that would still be faster than just using a single one, I would imagine. Compute queues can be run in parallel. I'm going to have to look into that because I was always under the impression that they were like individual queues that could be run in parallel. Like, why would they give me 16 if I can't use them that way? I'm not saying you're wrong. I'm just saying that surprises me. But yeah, I mean, like, we have all these different queues, right? Queue families, I should say. I don't know. Yeah, I guess that's the one thing that's a little bit annoying about Vulkan is it's kind of hard to like easily test something like this. right? Because your bootstrap is like 1,000 lines of code, right? So like even testing it outside the context of an engine is difficult, right? I suppose I could profile it though. I could crank up Insight and profile it. We are eventually going to cover this anyways, and using multiple queues and stuff like that anyway, which is actually going to be interesting because I know on MultiVK on M1 hardware, each of these is only one. And so you have to have like all the families look exactly the same, but each one is actually only one queue is available, which is super interesting to me. Anyway. Yes, I know it wasn't written. I didn't want to write it. Okay, so let's see. Where did I do that? I think it was in testbed main. I think it was, yeah. There it is right there. So we need to pull these properties from light properties, as well as this guy too, right? Because our cascade split multiplier is it's ultimately what calculates our cascade splits based on the camera frustum, right? And so that's what gives us that sort of spaced out, non-linear split, right? So it's basically like our first couple, to illustrate this, our first couple splits, I'll use this color. Like the first one is like here, right? Really super close to the camera. And then the next one is like here. And the next one is like here. And then this covers everything else, right? It's, it's basically something like that, right? So we need to expose these to the shader, as well as have these actually use the same thing that's sent to the shader. So what I am thinking is for the fade start and the fade distance, I think it actually makes sense rather for those to be part of the directional light structure. And this could be shadow fade start, shadow fade distance, right? And the reason I say it should be here is because ultimately the directional light is what the shadow is based on anyways, right? So I think it kind of just makes sense for it to be based off of that. So we have that. Let's see. Do I need anything else in the shader for right now? I don't think so. I mean, theoretically, I could use a vector or a vector 2 for this, right? But I don't think I'm going to. I think what I'm going to do, though, is I'm going to reserve some padding just to sort of square that out, right, in terms of memory. So we have directional light, which is going to be here. So in our global uniform object, directional light see, where was that? It was down here somewhere. There we go. So let's say our global UBO, directional light, shadow fade start, right? And then we can do the same thing here. Oops, shadow fade distance, right? And then I guess, well, actually, you know what? Let's keep these local floats, right? So float, fade start, There's that. Fade distance. Instead of shadow fade start, let's actually rename this to shadow fade. Let's call this shadow distance, right? Oops. So we'll call that shadow distance, and then shadow fade distance. I think that makes sense. On a quick search, I found the following. Up to Turing, all queues would pipe down to the same hardware queue with one additional queue for async compute and another for transfer. Ampere architecture introduced 2 simultaneous compute hardware queues. Okay, that makes sense. Well, and I think there's other work that we're also doing on the graphics queue that doesn't need to be on the graphics queue that we could also offload onto the transfer queue. We're not using the transfer queue anywhere near like what we should be doing. So that's a thing as well. Let's see. Okay, so our fade distance, we're going to add that 0.00001 just to avoid a divide by 0. And I think that's probably going to do it right now for this, right? So we're going to take this to-do out of here. And let's see, we called that shadow distance and shadow fade distance. So here, that's going to be shadow distance and shadow fade distance, right? Those are going to be the 2 things that we add to our shader config. So if we I'm going to do the terrain shader first, and then we'll come back and do the PBR shader, because the changes will pretty much be the same in both cases, right? So we need, let's see, the global. Actually, I don't think we have to add anything here because it's part of the directional light, except this now needs to be struct 48 because we added essentially a vector 4 to that. Yeah, okay, that should be it there. All right, so in the material system, we're going to need to make changes to support that. So if we search for directional light, I don't actually think we need to make any changes here. All we need to do is change on the structure and then change. Yeah, there's not actually any changes in the material system now that I think about it. The directional light's just fed through as is. Okay, so let's go to definition on the directional light. And we'll add a F32 shadow distance and another F32 shadow fade distance, and then a vec2 padding. Oops. Bonjlo, thank you for the follow. I appreciate that. That name's hilarious, by the way. Love it. Let's see. I've missed a couple of chats here. So on a numerical stability note, you might want to put the 0.000 correction directly in the divisor. Otherwise, it might be swallowed by precision issues in the add on line 245. So you're thinking put it here, essentially, instead of here. Or, oh, wait. Where are you saying to add this? Line 245 is blank. So Vulkan gives you 16 queues, but the OS driver schedules them to the same hardware queue. Gotcha. Unlikely to be a problem. Yeah, more or less. I don't think it's really going to be an issue for us. On the CPU side, multi-threading, isn't this called saturating a thread? More or less. Scheduling more threads than available cores. Yeah. I mean, saturation makes sense for that, right? Oh, yeah, relative number is hard to read sometimes, yep. Especially when you jump around. Yeah, that's true. You meant the add on line 244 might swallow it. Put it on 247. So you're talking here then. You're saying do that, essentially. I mean, that does make sense, right? I haven't seen that actually be an issue, but it's a good call out. Oh, you're talking about inside. So that's going to wind up being... You're saying that. Yeah, because that would be bad if that wound up getting clobbered. Yeah, okay. Yeah, that's a good call out. I might have just been getting lucky that it hasn't been clobbered. All right. So we have that there. So we actually need to modify our scene to include these properties, right? So I'm going to put in here shadow distance. And I'm going to set this to 100, right? Because we're going to basically default to 200, but I want to make sure that this actually loads it the way that it should. And we'll say shadow fade, if I can spell it right, distance. We'll set that equal to 5. Right? I keep adding those semicolons because I'm used to adding semicolons everywhere and it shouldn't be. All right, so we've added those there. We need to go to the simple scene loader. And let's see. Directional lights. Let me see. Where do I want to add this guy? config direction, position. So we don't have those properties that are used for anything else, and I don't think we're going to. So I think what I'm going to do is I'm probably just going to add these right at the end of this. So we'll do this just twice, and then I'll just modify the second one. All right, so we have shadow distance. Oh, you know what? Our point lights are eventually going to have shadow distance as well. We don't have that implemented yet, but we need to actually handle that. Okay. So let's do ads, because we have ads. All right, so for those of you who are new here, welcome, first off. And second, on Twitch, we are served ads for 90 seconds every 30 minutes. So I like to pause the stream so that nobody misses content during that ad run. So let me go ahead and check on the YouTube comments, because I can at least answer those. Hey, I just found your channel. How's it going? It's going well. How about you? Welcome. Glad to have you here. So we are actually implementing some new properties for our shadow mapping in terms of making things a little bit more dynamic tonight, right? So that's kind of what we're working on tonight. We already have shader hot reloading working, so now we just need to tie in some specific properties to that so that it works the way that we expect, right? So that's pretty much what we're up to. We've got about 10 seconds left on ads, and then we can continue. All right, and I think we're just about done. Yep, ads are done. All right, perfect. All right, so let's see. How long have you been working on it? The engine? So the engine has been in progress now for just under 3 years. We've done the entire thing either on YouTube video or on stream. So I'll just kind of give a quick introduction here. So what we're working on is called the Kohi Game Engine. So it's written in C using Vulkan as its initial rendering backend. We are eventually going to support Direct3D and Metal as well, and potentially OpenGL. It is cross-platform, so it runs on Windows, Mac, and Linux. Desktop, we have plans to eventually support iOS and Android down the road as well. It is completely free and open source. So if we go here, we can see that we have a GitHub repository available for it. It is Apache licensed, which means that it's free and open source for you to use however you want to use, commercial or not, doesn't matter. The only thing that I ask is that you just credit it and say, hey, I used Kohi. That's it, right? It is 100% free. It's 100% open source, meaning there will never be any sort of licensing fees or royalties of any kind. This is designed to be an educational resource. So we're showing the complete process of building a game engine from the ground up on video, right? And the idea is that it demonstrates the way of building a game engine from scratch. It's not necessarily the only way to do it. It's not going to be even always the right way to do it, right? We're going to experiment with things along the way, see what works, what doesn't work, change things along the way, and adapt and move on, right? And so the the idea there is that because this is a educational resource, that I don't paywall anything either here or on my YouTube channel. All of that content is 100% free, always will be, and so forth. So I do have links on here to like my Patreon and stuff like that. If you're interested in that, that's also here on the kohiengine.com. If you want to support my work, but it's completely optional, right? I don't charge for access to anything. Purely support here is purely optional. We do have a Discord as well with over 700 people on it so far. And yeah, that's pretty much it, right? So that's the project as a whole. It's also designed with a like a plugin mindset. So the renderer itself is a plugin, the audio system's a plugin, the UI system is a plugin, and all those plugins are optional up to the application to figure out what it uses, what it doesn't use. So the Vulkan renderer is a plugin, the Direct 3D renderer will be a plugin, and so forth, right? So the application can choose what it wants to use and how to configure that. If you want an ECS, you could use the ECS plugin when we make it. If you don't want to use an ECS, you don't have to, right? Yes, there's been some pretty cool discussions on Discord. I'm not always able to hop in and join those, unfortunately. I try to when I can. But yeah, there's definitely a lot of really smart people on there, right? Let's see. I found your channel with this 001 video. I was searching for some game engine tutorial series. My focus was on C++ OpenGL, though. Nice. Well, I'm glad you found it. I hope you found it useful. I did do a small series based off of WebGL, but that's not exactly the same thing, right? And that's several years old at this point. Love that it's open source. Looks awesome. Appreciate that. Thank you. Yeah. Yeah, I feel like educational resources should be free, right? And I greatly appreciate the support financially, of course, especially right now because I just found out today I'm getting laid off. But it's optional, right? And it's always going to be optional, right? I don't paywall anything, right? All right. So with that in mind, what we are doing now is we are adding some properties to our simple scene loader, which is basically our simple scene is, we're probably going to wind up renaming that to something else, like just scene maybe, because I was just going to make it super, super simple, but the more I think about it, I'm like, I think we'll just make it a scene and not have multiple types of scenes. We'll just have a scene, right? All right. So we are adding shadow distance in here. And right now, shadow distance only exists on a directional light. All right, so if we're parsing a directional light, we can use it. If you're parsing a point light, currently it is invalid to do so. So I'm going to throw a warning and say, cannot process shadow distance in the current mode. Point light. Eventually we are going to be adding that for point lights. We just don't have it yet. And that's going to be something we should probably add before we start building a game too, right? It is on the to-do. So what we're going to do, let me just move this over a little bit, is we're going to take the current directional light config, or is it, do we not have one? Oh, right, we can only have one, so we don't have a current. It's going to be, what did we use for that? Resource data directional light. Directional lights config. And instead of position, we are going to use shadow distance. And this is not going to be string to vec4. It's going to be string to F32. Right. We do not have shadow distance in the directional light config, so we're going to need to add that. So peak definition on that, and peak definition on that. And we'll add F32 shadow distance and F32 shadow fade distance. Right? So we've got that. And then we'll say error parsing directional lights shadow distance as F32 using default value. Okay, so basically if we fail to parse that, we're going to bleat about it, and then we're going to set resource data directional light config shadow distance to I think we're going to use 200 as a default, right? That way we have a reasonable default to work with in the event that that fails. Okay. All right, so we have that. We probably ought to just take this whole block and overwrite this, because this was the second copy that we made of that. So this is going to be shadow fade distance. Shadow fade distance on there. Fade distance. And then fade distance default here, we're going to do 25. And then obviously we need to bleat about this here if we try to do it on a point light, because it's not supported yet. Oh, this should be shadow fade distance here, and up here this is also going to be wrong. Shadow distance. All right, so now that's added in, passes over the properties to the config. We should probably define these defaults somewhere instead of doing them in line, because there's another place we're actually going to have to set that. Let's go up here. And we'll do a screw it, I'm going to do a define. Let's see. Shadow distance default. And we're going to set that to 200.0f. Not F32, just F. And then we're going to define shadow distance, shadow fade distance default as 25.0f. Right? And now we can actually just plug these in. Oops. Shadow distance default. And hit the wrong button. Shadow fade distance default. Right. We're also going to need to go to the top of this. I'm pretty sure. Do we have a default up here? We have point light array. Interesting. We actually didn't set any defaults on our directional light. I guess because it's possible that we don't have one. But we could technically create one and not set those properties, right? So we need to actually have some defaults for that. DSC, I'm not sure what you're saying there. Would you mind providing that in English, please? I'm not sure what language that is, but yeah, try to keep it to English in chat, please. Let's see. Simple scene implies a complex scene. Yeah, exactly. And because what I was initially thinking was like, this is just going to be a bare bones scene where we don't do any sort of spatial, what's the word I'm looking for? Not division. I can't think of the word I'm looking for, but spatial division, basically, like an octree, essentially, right? Partitioning, that's the word I was looking for. Thank you. Words. So yeah, yeah, spatial partitioning, like we weren't going to do any of that kind of stuff, but the more I think about it, I'm like, I could just make that stuff optional when you actually create the scene instead, right? So yeah. Let's see. So I guess up here we'll need to have some sort of... I guess I'll set the default here. I'll say resource data, directional light config, shadow fade distance equals shadow fade distance default, and resource data, directional light config, shadow distance equals shadow fade distance default. Nope, not fade. Not the fade version. Okay. So we should be covered on that, even if we don't create them by default. So if we don't add these properties, if we omit those properties, we will still use the defaults that come with that. Okay. So that should be good. The simple scene, when we load the directional light, directional lights, here we go. Okay, so if we have the name, then we take a copy of the name, the color, the direction. Okay, so here is where we actually do that. I don't know why this stuff is split on multiple lines, but let's do away with that rubbish. And we'll say scene, directional light. Oh, it's dir light. Data. Shadow fade distance equals scene config directional light config. Why is oh, Vim. I actually tried to translate that text in Google Translate and it like failed. Wasn't sure what it was actually saying. So config directional light config shadow fade distance. All right. And then we'll do the same thing and we'll just change this one to not be the fade version of that. Cool. So now we should have that. That should automatically get passed to the shader. We should be good on there. That's all we should actually have to do on that. And then over here on the other side, we can actually pull this from light properties now. So we can get rid of this and say state main scene dir light. And we want data shadow distance. Didn't we actually have like a convenience pointer to the directional light? So that's an interesting issue. This stuff should only probably happen if we have a directional light. Because like all these splits and stuff don't make sense. Like if we don't have a directional light, we don't actually run the shadow map pass. I mean, I guess this doesn't really matter, right? If we don't... This will just be 0, right, if we don't have it. So data shadow fade distance, right? Let's see. Okay, so let's just add a safety check in here. We're going to say if state main scene directional light, then we'll use that. Otherwise, we'll just set it to 0, right? Okay. Oh, there is one more property we need, which is the cascade split multiplier. That also needs to be in light properties. Okay. So I guess we need to actually add that in here. Shadow split. I'm going to call that bolt is equal to 0. I'm going to default this to 9.5. Right, so we need to actually do that. Should probably have a default defined up here as well. Shadow split mult default is 0.95 F. So resource data, directional light config, shadow. Did we not add? Oh, we didn't add it to the config, did we? We did not. F32, shadow split mult. Shadow split mult equals shadow split mult default. Right? Okay, so we have that. We need to add some parsing logic for that. So it's basically going to be the same as what we did before. Here we go. So it's essentially going to be the same as this. So this is going to be shadow split mult. And actually, point lights don't apply to this because we're not going to have cascaded point light shadows. So we can actually eliminate this block in this case. And this is going to be shadow split mult. Shadow split mult equals shadow split mult default. All right. So that should parse from our scene config now, and then in our simple scene, let's see, here we go. So we just need to do the same thing. So scene, directional light, data. Oh, we don't have it here yet. So we want shadow split mult. And then this just needs to be F32 padding. So we have shadow split scene config directional light config shadow split mult. Right. So we have that. Now this can come from do we assign the default on this actually in the loader? I don't remember if we did that or not. Split mult. Yeah, we did. Okay, cool. Right. Let's see. Have a good rest of the stream. I gotta go. It's 1:10 a.m. in here. Good night. All right, awesome. Yeah, I appreciate it, Taman. Have a good one. I'll send you a DM tomorrow when I'm on my PC. Fair enough. I appreciate that. Thank you. I will keep an eye out for it. Let's see. You're inspiring. Oh, thank you. I appreciate that. Seekum, heading to bed. Glad I came across your channel. I'll try to catch you another time. Have a good one. All right, I appreciate it. Thank you for being here. Appreciate that. We're about ready to wrap up for the night here, anyways. Actually. Okay. So let's see. We have that there. We need to do main scene directional lights. If we have that, we want to use main scene directional light, data, shadow split mult. Otherwise, we're going to use the default. We're just going to say, I guess 9.5. It's fine. Oops, that should be a colon. There we go. Okay, so we're pulling that from light properties now. Let's see. The only other thing I think we have to change is actually in our shader. We have one more thing in our shader to change. Because we had this padding here, I'd forgotten about the split. We're not actually going to use the split in here. Shadow split mult, but it is part of the structure that gets passed in. So this is going to be a float, if I can spell it right. Okay. I think that should be good to go. So we set the shadow distance to 100 in our scene file. So we should see that fade out happen sooner than the default 200. And technically that's also going to bring in our shadow maps too, so we have better resolution with them. So let's go ahead and run. Okay, so we must have messed up something in the terrain shader, because I'm not seeing that shadow on the terrain at all now. It's showing up on the regular model objects, right? The PBR shader is showing up. But something about this isn't right. So I'm not actually even gonna, I'm just gonna render dock it, right? So let's do launch. And I'm just gonna load up. And I'm gonna just capture the scene, the frame rather. Let's actually look at what's getting passed. So we want the render pass world. Oh, incidentally, we have ads. So for those of you who are new to the stream, I like to pause the stream once every 30 minutes for 90 seconds for ads, because that's when Twitch pushes those ads to us. We can't really avoid them, so we go ahead and we pause the stream, right? And I was actually just about to wrap up, but I guess not until ads are over. So we got about 40 seconds left on ads, and then we can continue. Almost done with ads. All right, so ads are dead. And what we are looking at here is, well, for one thing, strange. So it's still picking up our directional light as color and direction only. And you'll see that our next two values have actually fallen through to the next thing in line, right? Which would be view position. So this 100 is our shadow distance, and this 5 is supposed to be our fade distance. But for some reason, directional light is only picked up as being these two. It's color and direction. So I'm wondering, if I... Well, first off, did I actually save the shader? I don't know. Maybe that was the issue. I might not have actually saved the shader file, come to think of it. No, that's not it. All right, so what would cause that to happen? So if we take a look at, we have color, we have direction, and then we have another 4 floats. So we have 16, 32 bytes, 48 bytes. So I don't think it's an alignment issue. Take a look at the shader config. our directional light is marked as a struct 48, right? So it should be taking in 48 bytes. Is it possible I didn't save that? I don't think so. Let's just build real quick. And we'll run again. It's very peculiar indeed. This is the global scope. The directional lights is global. What would be this is only a vector. Wait a minute. This doesn't seem right. So that's a vector 3. Oh, and we round these two out with that. Okay, yeah, that actually is correct. Okay. What would cause it to not get... Because basically what we're doing in the material system is we're feeding in the directional light data, which is this structure here that we're passing in. So it's 2 vector 4s and 4 floats. So we literally shouldn't have to change anything here. And actually, funnily enough, I think we can actually jam this bias in there as the last value. Because I forgot that we had that thing in here, hard-coded. So that's actually what's going to become the last property. Well, I don't know for tonight. And I do have to get up early in the morning, so I think this is probably... Does render doc show shader source, seeing that the floats are actually present in the loaded shader source? Yeah, it does. Well, it technically shows the SPURV, but of course I already closed it out, so I'll have to get a new capture. So if you take a look at this, we go here and we go into the, we go into this render pass. This is one of the terrain chunks being drawn right there. So if we take a look at this guy here, all right, there's that. And then here is the shader module. Let's see. So that's the fragment shader. Here's the directional light. Oh, look at that. Wait a minute. Could it be? I think I know what the problem is, actually. And it's a little bit... So this is our fragment shader, right? But I think our vertex shader is actually going to be what's at fault for this, because it defines the same thing, because this is the global uniform object, right? So yeah, this is, I can almost guarantee, going to be the problem. This is where I really need to get shader includes working, so I don't have to do that, right? Yeah, I can almost guarantee this is going to be a problem. So let me... Because the vertex stage is first, it probably sticks with that definition right on through. Yep, there it is. So, we can already see that our shadow range is much closer, but if I back up about 100 units, we should see that fade out. There it is. Right, so we know that our new values are working. Okay, so what this means is, like, next time I think what I'm going to do is maybe try to come up with some ways that we can transform that on the fly, or maybe we can set a set this using our debug console, right? Because I've got some ideas for some enhancements to that would actually go really far with this. So what I'm going to do, get add shader hot reloading, move added shadow distance fade, added params to directional light. And I'm going to push this. And go into our repo. And let's get out of this feature branch, because I think we're done with it. So, let's see, do I even have... Okay. So we actually don't want to go into main. We want to go into 0.60, right? Since 060 is what we're working on, and this feature branch is part of that, that's the way we're going to roll. So create a pull request, just so that we have all this stuff sort of, this history here. And we're going to go ahead and squash and merge that. And we're going to nuke the branch. And now over here, I can do get version 060. And there we are. Right? It's looking pretty good, I think. So, that is where we're going to end tonight. We actually did wind up fixing it, which is awesome. I was worried that we weren't going to be able to, but yeah, thanks for the suggestion of looking at the shader source. I guess my brain was tired and I just didn't immediately think of it right away. But yeah, that is where we're going to leave it for tonight. Let's see. So I think for tonight, I'm going to raid Ferret Software. So for those of you who aren't familiar with it, it is a ferret rescue that is run by Pirate Software, who's another game dev here. You may or may not have heard of him. But basically he takes ferrets that are essentially in line to be put down for various medical issues, and he rescues them, gives them a permanent home, and uses the ad revenue alone from this stream that we're about to hit up to support that, right? Ferrets are extremely expensive animals to care and maintain for, and I think he's got like 22 of them or something like that. So I think it's a really good cause, and I like to support it wherever I can. So I really appreciate you guys being here tonight. Thank you, and yeah, I will see you guys on the next stream. So see ya.